With today's technological advances, complex laboratory processes that were once conducted on full-size laboratory equipment are now done on handheld-sized platforms. This lab-on-a-chip technology carries obvious benefits, opening up access to complex medical diagnostics and chemical processes in remote locations. But problems persist in driving fluid flow at the miniaturized scale required for lab-on-a-chip. As fluidic platforms shrink, it becomes more difficult to force liquids through their tiny channels. The tiny pumps and valves can't handle large resistances or pressures, and miniature devices are limited in the number of pumps and valves they can support. As a result, small microfluidic devices are typically connected to large external modules for pumping and controlling fluid flow. So, instead of a lab on a chip, we get a chip in a lab.
Lab-on-a-chip devices incorporate all of the required liquid handling needs and shrink in size only, not capability. We develop simple components such as magnetically driven microvalves, micropumps, and flow sensors, the building blocks of our technology called Splash. The key innovation of Splash is how the pumps and valves use the strong forces between two permanent magnets. We use these forces to move liquid through complex microfluidic channels or to switch the direction of the flow, sometimes even without electricity. These micropumps and microvalves allow us to add more processing steps with minimal peripheral components. We can generate as much as 50 psi pressure to drive the flow. In the self-power version of Splash, the sliding motion of the card activates an array of magnetic pumps and valves, executing a complex series of laboratory steps. Every component can be laid out to meet the needs of a specific application or a process.
Splash is more than just a product, it is also a methodology. We create customized systems by breaking down processes into basic actions, such as fluid motion and valve control. It's like solving a puzzle. Based on the steps involved, we design a driver circuit and a microfluidic card to complete the process. We use rapid prototyping methods involving laser-based micromachining and lamination to integrate magnets, membranes, and microchannels to construct the Splash platforms. Our advanced manufacturing method could allow us to go from a process flow diagram to a working device within the same day. To integrate more complex processes, we've also developed a battery-powered variant of our technology that uses stepper motors and Raspberry Pi computing units to execute complex operations. We have also developed miniature flow sensors as companion products that can be integrated with our microfluidic cards to enable feedback, improve precision, and provide control.
We are able to integrate all of the process flow steps for a given chemical or biological process in a small footprint. And it's affordable. We imagine a future where these devices are mass-produced. It is likely there are applications we haven't even considered.
Splash solves the fluid flow problems that come with making tiny microfluidic devices. It's portable, affordable, electricity-free, and adaptable to numerous applications. Splash puts sophisticated microfluidics processing right at the point of need and makes it available for difficult and remote locations, from a glove box to a remote medical clinic or even in outer space. The future of microfluidics has arrived, and it fits in your pocket.